Now, let us look at some simple examples to understand potential energy. Pull a rubber band on one hand and pull the band on the other hand. The rubber band will get stretched. Now, release the rubber band from one end and you will see that the band returns to its original state. Why do you think the rubber band returned to its original state? It is because the band acquired energy when it was stretched, and this energy causes the rubber band to return to its original state. Now, take a toy car and wind it with its key. Then place the car on the ground. You will notice that the car starts moving. From where do you think the car got the energy to move? In all the examples, the object stored the energy from the work done on them. When an object doesn't use the energy transferred to it to cause any change in its speed or velocity, then it is stored by the object in the form of potential energy. You transfer the energy when you stretch the rubber band or wind up the key of the toy car. When you stretch the rubber band, the work done by you in stretching it is stored as its potential energy. And when you wind up the key of the toy car, which compresses the spring inside of it, the work done in compressing the spring is stored as its potential energy. Now, let us perform a new simple activity to understand potential energy. Take a ball and raise it to a certain height. The ball now has the capacity to do work. Then release the ball and you will notice that it begins to fall. Now, what do you think will happen if you drop the ball from a greater height? The ball that falls from a greater height will have a greater velocity when it reaches the ground. We did more work to the ball when we raise it to a greater height. Thus, it possesses more energy. Now, take a bow and an arrow. Place the arrow with the bow with one end supported by the string. Now stretch the string and release the arrow. You will notice that the arrow flies off up a certain distance. The bow stores the potential energy when the bowstring is stretched, and then this energy changes to kinetic energy of the flying arrow. Now, let us understand what happens to the potential energy of an object when raised to a certain height. When an object is raised to a certain height, work is done on it by us against gravitational force. Due to this, an object possesses more energy when raised to a greater height. This energy is known as the gravitational potential energy. Gravitational potential energy is defined as the work done in raising an object from the ground to a certain height against gravity. It means that potential energy is equal to mass times gravity times height, or simply PE is equal to mgh. That is the formula for potential energy. The energy that the object possesses by which you affix motion is known as kinetic energy. Let's consider a smooth round ball. If we push a ball a little, it will be set in motion. The rolling ball, by virtue of its motion, is capable of doing work. Here, it hits an object such as a small wooden block, pushing the object a bit beyond its initial position. The energy of this moving ball is its kinetic energy. An object's kinetic energy depends on both mass and speed. Let's go back to our ball. This time, we will place the ball on an inclined plane. If we place the ball on top of the incline and let it go, it will quickly roll down, hitting the wooden block with greater energy than before, and still pushing it forward. But note the new position of the object. This time, it has been moved farther than before. Now, let's increase the inclination of the plane and return the wooden block on its original position. Place the ball at the top of the incline, letting it roll freely downhill. The ball will hit the wooden block with even greater force, pushing it much farther. Again, note the new position of the wooden block, which was pushed much farther because of the ball's increased speed. This helps us see that the kinetic energy of an object will increase as the speed increases. Let's slightly modify our experiment. Take a larger ball and let it roll down the inclined plane. The ball will hit the wooden block with a greater force, pushing it much farther. From this, we can say that the kinetic energy also increased with an increase in the object's mass. If we apply an equation to what we have seen, we would say that kinetic energy is equal to the half of the mass times the squared of its speed, or KE is equal to 1/2 mv squared, where m is the mass of the object and v is the velocity. Kinetic energy is measured in joules. When the mass of the moving object is increased 2 times, its kinetic energy will also be doubled. When the velocity of the object is increased 2-fold, then its kinetic energy will increase 4 times.